Hello, this is Jan. I'm the developer of a C++ plugin called SimpleForest. It's a plugin to model trees or forestry scenes. I developed it for the Computree platform, which is an open source platform designed for tree modeling. And so what you see here on the screen is a forestry scene with round about 40 trees. I think it's a German forest. It was scanned with terrestrial laser scanning in winter time, and so we have all the broadleaf trees are leafless, and the cloud quality is quite good. So I made a big processing chain to process a cloud. We can see here on the left of the screen it's 46 different steps to produce those results, and the cloud which I used was round about 1 GB sized. And I would like to thank Tobias Meissner at this time and his labs from the University of Leipzig, and thanks for letting me access to this cloud. It's a really nice cloud. So as I said, the quality is high. The cloud size is over 1 GB raw data, and we will see now how we can produce those models in without much details they are given in other tutorials. So the script, I saved these 46 steps into a Computree script, and I will share the script, and its name plot leafless full QSM. That's the name of the script, and you will find where I share the data. So now you see the complete forest scenery, and our first goal is to produce a digital terrain model, also called DTM. I give you a short overview over the first 6 steps. The first step is to import the cloud, and then I just reduce the point intensity a bit to improve processing, to save up some computational resources. So then we have 2 ground filters followed, and just like a quick statistical outlier filter to further improve. So all these 3 steps, they get rid of all the vegetation you can see here, all the trees, all the undergrowth, and the ground points remain. And then I do the real terrain model fit with the 6th step. So I will remove the scenery, and I will show you now just the filtered ground points, and I give it color code by height information. So you can see here red, this means these points have slightly increased z coordinate, they are higher than the green points. On this is a forestry road with an intersection on the left and the right. The green areas here is true forest, where also all the trees have been located. So I used these points which you see here. I produced with 3 filtering steps. Details are given in the terrain modeling tutorial video. It's the plot model tutorial number 1 you will find in my YouTube channel. And I just blend also again the DTM, and we can see we have points above and points below this DTM. That's a measure of quality, so I didn't do a misfit in the terrain modeling. and we can also clearly see here the forestry road. So this is the first 6 steps. Details how to set up those 6 steps are given in terrain modeling tutorial. So the next goal is to extract different trees, isolate them, segment them from this whole scenery. We have DTM, and we will use the DTM also a bit. And step 7 to step 15 is like the how to produce segmented tree clouds. So again, all details are given in another tutorial video, the segmentation tutorial, and please watch this. I just give you a quick overview. So we can produce with these first 3 steps. What we do here is we make different slices cut about the DTM. So first we cut just slightly above the DTM to extract the full vegetation, but to remove the ground points, and then we create just a slice at the root of the trees, so the first meter. So as the root of the tree, as we have here still side connections, we do some filtering again to isolate those roots more, and then we do a clustering. So then we have the first meter of the of the trees clustered. These clusters are seed clusters for the following Dijkstra-based segmentation and the Voronoi-based segmentation. So let's have a quick look. So we have here cut out slice just above the DTM, at the root of the trees. And as I said, all the stems are still connected with side branches. So we had a few filtering steps, and now all these connections are gone. Now we can cluster this slice, and to get our seeds, which we use for the following procedure. I colored each cluster differently now, and we can see the clustering worked. And now we just extrapolate this clustering information to the complete forestry scenery, and I will again one more time give them different colors, and we can see the clustering did work. Each tree is colored differently. So that's it for the segmentation. So there is no dedicated tutorial for the next 2 steps. It's just the same step. We repeat it twice, and all these clusters they will be split into really small trees, smaller than 2 meters, up to 5 meter I think, and everything large. So we just group the models. So we can see here this is really small trees, and so then we have intermediate sized trees, and the really large trees. We did so to be able to process those trees differently. So for the next part there is again a dedicated tutorial video. It's about to prepare the segmented clouds It's called preparation of segmented clouds. This is step 18 to 24. We just have some filtering operations. So again, we do with step 18 and 19, we cut out here the lower root of the trees. We do some stem filtering, then we merge the it's similar to the seed segmentation. Then we merge this lower slice again with the upper slice. This is 22, and then we just do 2 more filtering steps. So if we go to the model, we can see that we removed a lot of noise at the roots, and so I just blend over the original here you can see this was removed, and if we look above we might also have a bit visible result. Not really, but a tiny bit was removed here. So watch the dedicated preparation of segmented clouds tutorial to get more details, and we will proceed in the pipeline. So what will follow is to finally build the quantitative structure models, the tree models. So we want to produce cylinder models out of these segmented and prepared clouds. So for these large trees, this is step 25 to 32, and then we export the trees. So what you need to really look at is to give a proper part in the exporter, otherwise you have lost the information when you close Computree. So the clouds which you see are again, there is a dedicated tree modeling tutorial which discusses how to set up these steps. So just basically spoken, we use each cluster to produce a QSM. This is done here with the first step. It optimizes 3 parameters, so a 3-dimensional search space, and each tree is modeled so round about 350 times, and the best model is then chosen as a result. That's why this step takes 2 hours and 8 minutes. So we do filtering on the tree model. Then this is just another point processing step. So it uses a cylinder model and a point cloud to get a segmented tree cloud into 3 clusters: the stem, the medium-sized branches, and twigs. And so each of these clusters can get different parameters. So instead of 3 parameters, we can optimize now 3 times 3. This is 9 parameters, and so there is a lot more optimization going in the advanced modeling routine, and this takes up to 7 hours. Each tree is modeled more than 600 times here, and also the QSMs have a lot more cylinders than in the first step. And then there is just again some QSM filtering steps followed up to step 33. So I will just show you the first models which have been produced. Uh, the quality is not really good. There is also no filtering yet, but also only three-dimensional parameter search. And after all these processing routines which I talked about, we can finally get the large trees in really high quality, and we can see this is a final result. And here we see an error. There is just a second tree getting into our limited, I'm sorry for the coughing, into our limited area from the side. And so we have here a segmentation error, and that's why the tree model looks bad. All the other tree models in the center of the cloud look relatively fine. Here is also, this tree is, it's a larger tree which just leaves our area. There is again a segmentation error. The other tree models look really fine. So I can colorize them a bit nicer. And that's the tree modeling part. Watch the dedicated tree modeling tutorial. Here I give more details. So we have seen how to model the large trees, and now as we remember, there were also small and medium-sized clouds. The small clouds I throw away. It's smaller than 2 meters. There is no biomass contained in those trees, and they would need special treatments. But the remaining step 34 to 46 is for the medium-sized trees. So again, step 34 to 40, this is just filtering of the medium-sized clouds, and then the remaining steps is QSM modeling for the medium-sized trees. And there is just a tiny bit difference in the modeling routine. Before we had a preliminarily modeling in 3 dimensions, and then an advanced modeling in 9-dimensional parameter optimization. And here we just optimize parameters in 3 dimensions, because the clouds are just not big enough to justify higher parameter space here. So I will quickly show you the results. So first let's remove the large trees. Then we can see the prepared clusters. They look decent, but we can see here there is also some really nonsense which is still left over. Also, so in the back this is not good. Here is trees too close to each other, so this will result in worse modeling than the large trees. You could give more you could improve further the cloud processing for those trees, but we can see here there is clearly like 10 misfits or even more, but also good tree models like here. And we can just again quickly colorize those tree models. So you would need to find in R or whatever statistical software you use some tools. I mean, it's not hard to, let's say this tree has a volume of 500 liter. This is much too much for a tree which is just 2 meter height. So you have to remove them statistically. Um, that's it. That was the full pipeline. Thanks a lot for listening, and I hope you enjoy working with my software. So one more time, we quickly see the complete scenery results, also with the large trees and the DTM. And I just wanted to tell you that I didn't spend time in optimizing the parameters here for these tutorial videos. In general, I use standard parameters. You can improve the quality also by far, and with some more interactions with the software. For me, it was already a lot of work to make all these tutorials, and I'm quite happy that I made it until here. But if you do in a scientific project a little bit more work than I did for tuning the parameters of all these steps, then you also might get even better results. Um, I think overall the quality is really good. I mean, this is a full automatic method. After you set up the parameters, you can just take the same script and run it on a different plot, and the results are quite convincing. Uh, the majority of errors for the last large trees are segmentation errors caused as there is a hard cut of the point cloud. So this is definitely another tree model, as I said before. And also, if you just focus on the center area, the errors are a lot smaller, and that's just what I wanted to give you as an advice. So thanks one more time, and goodbye.